The topic of this video is on triangle congruence, but really with a focus on how else you can try to get congruent sides and angles. So I just want to make sure that we are clear that sometimes you'll just be given those congruent angles and sides, but sometimes you have to do a little moving or looking around for some. So the first I want to talk about are vertical angles. This was discussed in a previous video, but I just want to make sure we're really clear on a vertical angle is kind of a cross an X-like pattern, and it allows for anything across that X to be congruent. So vertical angles allow us to get a set of congruent angles. Okay, more like across the X. The reflexive property is also one that we've been using quite a bit. So with the reflexive property, that's saying like anything that's shared. So sometimes it's a shared side, sometimes it's a shared angle. We can state that side or angle is congruent by the reflexive property. So in this case, I could say that GJ is congruent to JG, or NO is congruent to NO. And that's because of the reflexive property, because this side is in triangle 1 and is present in triangle 2. Same thing here. That side length is present in both. So the reflexive property, or when sides or angles are shared by both triangles, we can say they are congruent by the reflexive property. All right. The next two I think are a little bit harder, but let's start with the parallel lines first. So remember that when we see these arrows here or here, it means that we have parallel lines. So if I were to draw these parallel lines to extend them a little bit so we can see them, this line is parallel to this line. And we want to use a transversal that is touching both triangles. So in this, we have triangle 1 on this side and triangle 2 here. And so I'm going to highlight this middle line here that's touching both triangles, which is this line right here. Okay, the line that's going in between them. So you want to be able to say or use angles that are touching both the blue and the purple, or both the highlighted and the parallel line. So in that case, I've got this angle here and this angle here. Those are both touching the blue and the purple, the highlighted and the not, and they're both in the triangles I'm trying to find. So this allows us to say that this angle is congruent to this angle. All right. And so when we have parallel lines are helping us, or are creating congruent angles within the triangles, I should say, right? You want to be on the lookout for alternate interior angles. Okay, it doesn't mean they'll always be that way, but there's a good chance that they're going to be alternate interior angles. Let's take a look at this one. This one has 2 sets of arrows, and that's because we're going to use both sets of parallel lines. So let's use the bottom set first. So if I extend out my parallel lines here, and I look at, I've got triangle 1 on the top and triangle 2 on the bottom, I'm going to highlight that transversal that's in between the 2 triangles. So I know there are other lines, but I want the one that's touching both triangles. So I'm going from green to pink. So when I do that, I've got this angle here and this angle here. Those are alternate interior angles. And that's, I can't say this angle right now because that's stopping at black. So I need to change directions here. So I'm going to go ahead and make this set of parallel lines now. Using the same transversal, just now that red that red parallel line, I could see that pink and red can create some equal angles. So I've got this angle here and this angle here. So in this picture, I've got an equal angle, I've got an equal side, or I'm sorry, an equal angle, another equal angle, and I do have a side length, and that's the one in the middle here. So these two triangles will end up being proven congruent because I have enough information with those parallel lines and the transversal. Last but not least is that you're going to be able to use properties of quadrilaterals to help you. So sometimes you'll be given something like given rectangle ABCD, or parallelogram ABCD. So you can use some of the characteristics from these to help you prove things. So it could be that there are equal sides. You could say there are 90-degree angles. You can say there are parallel lines. So knowing your characteristics of those quadrilaterals, if you're given a quadrilateral, because it was named such, you then can use it. Now, you can't go by the look of it. It has to be given that it's such. But if it is given, you can use it. All right? There are 4 other lines that you might come into contact when you are doing triangle congruence. So one of them is a median. So a median's purpose is that it finds the midpoint of a segment, right? So let's say this is labeled triangle ABC. And let's say this is point X. So it might say something like BX is a median of triangle ABC. If it says that, that median means that point X is the midpoint. Okay, and if point X is the midpoint, midpoint means middle, right? That's what this means. It means middle. So if I have the middle point, then I can therefore say that I have a congruent side. I could go forth and say AX is congruent to CX because of that median. So it doesn't do anything to the angle. It only creates a congruent side. A perpendicular bisector is pretty amazing because that gives you 2 things. So, and it comes from both of the words here. So it comes from perpendicular and bisector. So perpendicular, remember, is creates 90-degree angles, and bisector means to cut in half. So if I run a perpendicular bisector through this segment, or through that angle right there, essentially what I'm creating at this point, so let's name this ABC, and this can be point W. Point W is creating a 90-degree angle, okay? And because it was bisecting, it also created equal segments here. So a perpendicular bisector, so it might say something like BW is a perpendicular bisector of triangle ABC. So if you know that angle, and notice I can't say angle W because it's 2 different ones. So angle AWB and angle CWB are right angles. We would know that, right? And then we also know that AW is congruent to CW. So this allows us to get some angles and some sides. We also just have a plain angle bisector. So an angle bisect, remember again, bisect means to cut in half. So an angle bisector, let's label this again ABC, and let's say this is Z. So this might say BZ bisects angle ABC, okay? So if that's bisecting the angle, that means it's taking this entire angle and cutting it in half, which will leave me with 2 equal parts. So this creates congruent angles. So in this case, I would say angle ABZ is congruent to angle CBZ. Last but not least is an altitude. And an altitude runs straight down. That is terrible. That's not a straight line. So sorry. Runs straight down, and all it does is create a 90-degree angle. So line straight down, but will always create a 90-degree angle. Okay. So just keep that in mind if you're ever given that vocabulary word, that we would be able to say that angle BXC and angle AXC are right angles from that vocabulary. So then we did a few practice problems that go with these. So I was going to kind of show you some of those that kind of walk through this, and I just have 5 highlighted here. So in this one, it's reusing that idea of vertical angles. So you can see that in this picture, we would be able to say this extra piece that we need is here. And once we have that starting at an angle side with no marking and moving my way around, this would be, these two things are congruent by angle side angle. So that would be here. And then putting our triangle congruence, let's say it's BAE, that would be congruent to DCE, excuse me. And that's not the only answer. You can do that triangle multiple ways. It's just the way that I wrote it. For this one, this is using the reflexive property right here by sharing that side, which remember we can mark with 3 lines to say that that's congruent. So yes, these are congruent, and that's by side, side, side. And I'm going to start here, go to 1 and then 3. So triangle LEO is congruent to triangle VEO. On this one, I have to use the word midpoint. I was given midpoint, so T is the midpoint of WR. If it's the midpoint, then it's the middle, which means that this segment is congruent to this segment. I know a lot of people a lot of times want to say that this angle and this angle are congruent, but you cannot right now. Those are not, those may not be vertical angles, so you have to be very, very careful. So we can only go off of what we know for sure. So these two are congruent. And then I have a side, and then I have an angle, right? So if I start with my angle and side not marked, and I move my ray around, which I'm actually going to go the other way, just so that I don't spell a word I don't want to. So when I do that and I go around this triangle like this, I hit a side, and an angle. So because of that, that's not a congruency theorem. So these are not congruent. I have 2 left. I chose a parallel line one just so you can kind of see. So the first thing you need to identify is where are the triangles. So here is triangle 1, and the second triangle is, oh, did I hit undo? The second triangle is there. Okay, so I've got 2 different colored triangles there. I need to pick a transversal that hits both of them. So the transversal that I'm going to do that's touching both blue and green is this one right here. I'm going to also highlight my parallel lines just so I can see the colors, because I want to make sure that, you know, it's touching the pink and the orange. So when I do that, I can see that I've got an angle here and an angle here. Those are both touching the pink and the orange, pink to orange. And thankfully for me, one is in the blue triangle and one is in the green. So from there, I also have a side marked here. So I have side and angle, and then I also have this by reflexive property. So these also would be congruent by side, angle, side. And then if I started start here and work my way around, let's say it's HFG, this one would be EGF. Last one, we've got IH is bisecting an angle. So this is the angle that we're talking about, and that angle is bisected, leaving me with 2 congruent angles here. I also then have this middle side that they're sharing, so that's going to be congruent as well. So I've got an angle, I've got a side, and then I've got this 90 degree. So yes, these are congruent. And that's by, it looks like angle, side angle. And then if I do my, I'm going to do WHI. So here, here, and up. That's going to be W or SHI. So hopefully, and again, these kind of take more practice. It's, you know, you just have to keep looking at those diagrams, keep trying to figure those out and try to find equal parts and equal angles. A lot of times if you're trying to find them, where these things are hidden is usually when the triangles are touching. If they're not touching, there's really not a lot you can do. All right. If you are struggling with this content or just lost, please, please, please reach out to one of us so that we can help you.